Let's go on to entity extraction. So there's, as we mentioned, there's two basic approaches. There's dictionary-based extraction and model-based extraction. So dictionary-based extraction, or at least the one we're using here, uses the iCorsica algorithm. It's a essentially it's a tree data structure of tokens that you use to search through text without having to backtrack. That means it's a pretty efficient way to do pattern matching when you have a large number of patterns. It requires a dictionary or word list, essentially a list of names and aliases for you to use to create the tree structure. But it doesn't require any training data, right? It's just dictionary-based approach. The model-based ones, deep learning is the most common now. Conditional random fields, I'd say, were the most popular, before deep learning took over. It's probably before about 5 years ago. Even though CRFs, as they're more commonly called, are still pretty competitive and pretty useful, and don't require quite as much data to train. Though I don't think any of them have the state-of-the-art benchmarks anymore. So the iCorsica algorithm. So this is a very simple example of the tree structure that you have. So here you have the word acute, and then bacterial rhinusitis, or you can go acute rhinusitis, and they point to the same entity that we have stored in the tree. So they have the same entry there. Here we have common and cold, that points to the common cold entry. What makes iCorsica efficient is that there are extra links in this tree structure, so that if, let's say, I find acute bacterial, and then the next token is infection, rather than rewinding back where I'm searching through the text, there's actually a link maybe somewhere else in this tree where we have bacterial and then infection, and it will search there. So I actually make only a single pass through all my text searching for the entities. So the pro is that no training data is needed. You only need a list of names and aliases, and you're ready to go. The cons are that it will only find the entities in the alias list, and it doesn't use context, which means that you can get a lot of false positives. So, for example, there's a protein who one of its aliases is April written in all caps. So if if you had a corpus that's talking about a global pandemic that became large in March and April, well, that's going to get a lot of false positives. So that means that you're going to have to essentially remove that alias and maybe even that protein from your data set. On the other hand, model-based approaches, they predict which tokens are part of the entity, sort of as a classifier. The benefits are that it identifies based on context. So even if you've never seen that particular disease or compound or protein before, it can potentially identify it. Also, it can be tuned to different data sets. With the dictionary-based approach, it's just, there's no actual tuning. You can adjust your text processing if you want to try, have it work a little better, but there's no real tuning you can do. The cons are that you need to get training data. Training data is relatively straightforward for humans to gather for most NER problems. The difficulty is that when you get to these domain-specific ones, it gets a little bit harder for just general people to find all the references in the text. And deep learning, of course, requires a lot of data, so it'll be even harder. But there's a way you can kind of get started on a model, and that is by bootstrapping. So the approach you go with bootstrapping is that you run your dictionary-based approach and you output it in bio format. So that's what we have here on the right. So here we have the influenza virus is divided into different types and subtypes. Influenza virus is an entity mention. So we have B here for the beginning of a disease reference, and we have virus because it's inside a disease reference. So now we output in the bio format. We have to make sure the tokenization is consistent between them, because if tokenization is, if you're let's say fine tuning a pre-existing deep learning model and it expects a different tokenization, you need to be doing that tokenization for your dictionary-based approach that you're using to bootstrap. So however you're doing it, just you have to make sure you the same tokenization and whatever text processing you're doing is the same between your dictionary-based approach and your model building approach. With conditional random fields, it doesn't require as much data. It's a simpler model. So that's sort of a double-edged sword there. It's good because it's simpler, requires less data. It's bad because it's not going to be able to learn as much. And there's also fewer open source implementations. It just was never got quite as big as the deep learning stuff, though there are good implementations out there. Deep learning, of course, that's the state of the art. It does require a large amount of data, and it can be slow to run without a GPU. Now, if you're using just Word2Vec for your vector representations, for turning your words to vectors, it won't be that slow. The difficulty comes when you're using something like BERT plus complex neural network. Then what you have is you have to run this neural network at prediction time. And if it's a very complex one, it can be much slower than other approaches. So these are some things to take into consideration when you're extracting the entities.